Hi everyone, in today's lesson we are going to discuss limits day 2. Our goal will be to evaluate limits algebraically now using direct substitution and factoring. So you're going to see a problem just like this. It's going to say evaluate each limit algebraically, and it's going to give you this. It is not going to give you this picture. I purposely put the picture there just to show you what's happening. So if I give you the picture, if I give you the equation like this and I say evaluate the limit. So I want to find the limit as x approaches 3 of this quadratic. So what you would do algebraically, your first step is always going to be to use direct substitution. So step 1 is direct sub. I'm just going to abbreviate to say direct substitution. Always, 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 that is your first step. So I'm going to do the work over here. So I have negative 2, 3 squared, plus 16 times 3 minus 32. So go ahead, take a minute, pause the video, type that into the calculator, and then hit resume when you're ready for the answer. All right, so you should have gotten negative 2. So that's it. That's the answer. If you plugged it in and you got a nice number, the answer is negative 2. So I want to show you with the graph why the answer of negative 2 makes sense. You're not going to have the graph on the questions, so I just wanted to just show you a little bit here. So we have when x is 3, which is here, the y value is down here, which is negative 2. So we can clearly see that the limit from the left and the limit from the right both approaches the same y value of negative 2. So a limit is a y value that a graph approaches or may not reach. In this case, it reaches it. The y value from the left and the y value from the right are both negative 2. So to solve algebraically, my first step was direct substitution. I got a pretty number and it checked out. Let's look at example number 2. So this is what we call a rational function. A rational function has an asymptote, a vertical asymptote. See, it has these little branches right here, and it even has a hole right here. So we'll cross that bridge when we come to it, but I want to find the limit as x approaches negative 4. So again, you're going to pretend like this picture is not here, and we're going to follow step 1. Step 1 is direct substitution. So I'm going to go ahead and plug in negative 4 plus 7 over negative 4 squared plus 16 times negative 4 plus 63. So go ahead, pause the video, type that into your calculator, and then hit resume when you're ready for the answer. Okay, so for the top I got 3, and the bottom I got 15, and when I divided them I got 0.2. So this is my final answer. Let's just prove to make it, see if it's right. So the limit from the right must equal the limit from the left. So here's the limit from the left, and here's the limit from the right. It looks like that small little space right there is the y value, and it looks like it is very small, so I don't see why it can't be 0.2. So this hole right here is something I want to discuss now. Let's move on to another set of examples. So example number 3, we'll say, is this one right here. This is the picture of what this rational function looks like. So let's follow the steps because remember the picture won't be there for you. So step 1 is always direct substitution. Okay, so let's do that first. So I'm going to plug in negative 4. All right, so again, pause the video and then hit resume when you're ready. Okay, so this one, you should have gotten 0 over 0. Now, 0 over 0, you should be thinking, this is undefined. We can't have 0 on the bottom of a fraction. So when you see 0 over 0, this means that there is a hole in the graph. But we know that we can still take a limit if there's a hole in the graph. So look, the limit from the left and the limit from the right still approach that same y value of negative 3. So graphically, we know the limit is negative 3. How in the world are we going to get that algebraically if we don't have this picture? So this is where I'm going to introduce step number 2. So step number 2 is going to be to try factoring. So let's look at this top. Can I factor it? Well, let's see. Let's add multiply. What numbers add to 5? That multiply to 4. So that would be x plus 4 and x plus 1. And I'm going to leave the bottom just the way it is because I can't factor x plus 4. You should be noticing something. These x plus 4s should cancel, and I'm left with x plus 1. So basically what you just did was you simplified it by factoring. So technically, step 3, we can now say, is resubstitute back in. So I'll say try again. Try again is a good way. But now we're going to say we want the limit as x approaches negative 4 of, now we'll say x plus 1. So we're doing the same limit, but instead of this fraction, we're writing the simplified version, which is x plus 1. So let's try again, and let's directly substitute. So we're going to plug negative 4 plus 1. I put in negative 4 for x. That gives me negative 3. So see how now I have my limit of negative 3? So what this process here of factoring and canceling is you're theoretically removing the whole from the situation and making it easier to solve. All right, good job with that one. Let's move on to the last one. So the same concept, I want the limit as x approaches 4 of this. So you should see there's a hole at x equals 4, but the limit should still exist because the limit from the left and the limit from the right still equals this y value of whatever it is less than 1. So how would we do this algebraically if the picture wasn't there? We would try direct substitution. So let's do that. We would plug in 4 and plug in 4. So take a minute, pause the video, and hit resume when you're ready for the answer. Okay, so I got, again, 0 over 0. So what that tells you is that there's a hole in the graph. Now, half of you are probably thinking, why do I need to do that if I already see it? Because if you type it into the calculator, you won't see the hole. So it's really important that we do it just algebraically, that we just see the 0 over 0. So we know there's a hole. So we have to factor to get ourselves out of the hole. So step 2 here is going to be to apply factoring. So I'm going to leave the x minus 4, and I'm going to factor this by add multiply. What numbers add to negative 6? That multiply to 8. So that will be x minus 4 and x minus 2. And you should notice the x minus 4's cancel. We're left with a 1 on top. Don't forget that. So as a simplified version, it's 1 over x minus 2. So step 3 is to try again and resubstitute. So we want the limit as x approaches 4, but now of 1 over x minus 2. So we're going to direct substitute 4. 1 over 4 minus 2. 4 minus 2 is 2, so the answer is 1/2, which looks very much like it was supposed to over here. Okay, so I'd like you to write down this problem, and obviously the question is evaluate the limit. But notice there's no picture, so this is really what the type of questions that you're going to get are going to look like. So the only way to tell if we get 0 over 0 is if we plug in our number. So our first step with any problem is going to be direct substitution. So let's plug in 4. So 4 squared minus 4 times 4 over 4 squared minus 3 times 4 minus 4. So again, try it, pause the video, and tell me what you get. All right, so for the top I got 0, and the bottom I got 0. So that's perfect. This tells me that there is a hole. So we know the only way out of the hole is by factoring. So the next step should be to factor. So we're going to factor the top. So I notice on the top there's a GCF of x. And I'm left with x minus 4. On the bottom, I'm going to factor by add multiply. What adds to negative 3? That multiplies to negative 4. And that is x minus 4 and x plus 1. We'll notice the x minus 4's cancel. So I'm left with x over x plus 1. So the last step is to try it again. So resubstitute back in. So we want to now take the limit as x approaches 4, but now of x over x plus 1. So same problem, but instead of this fraction, we're putting this fraction. So to try it again, we're going to do direct substitution. 4 over 4 plus 1, which gives me a final answer of 4/5. And that's it. That's the process that you want to be able to do without the picture. All right, let's try one more. All right, you guys actually do this. Pause the video and then hit resume for the answer. All right, so first step, direct substitution. So the top should be negative 5 and the bottom is 4. So you were probably thinking, hey, there's a fraction, it might be 0 over 0, but that's not entirely the case. Since I didn't get 0 over 0, my answer is just 5 over 4. So this one was direct substitution only. Awesome. Let's try one more. All right, so if you want, pause the video and you try it on your own. I'm going to try direct substitution first. Negative 3 squared plus negative 3 minus 6 over negative 3 squared minus 9. When I do that, I get 0 over 0. Therefore, that means I have a hole. So the only way out of the hole is to try a little bit of factoring. So factor the top by add multiply. So what adds to positive 1? That multiplies to negative 6. And that's going to be x plus 3, x minus 2. And on the bottom, you should recognize that x squared minus 9, this guy, is dots. So that's x plus 3, x minus 3. And the x plus 3's will cancel. And our simplified fraction is x minus 2 over x minus 3. So we're going to try again. And we're going to take the limit as x approaches negative 3 of this fraction x minus 2 over x minus 3. So direct substitution, negative 3 for x and negative 3 for x on the bottom. So negative 5 over negative 6, which reduces to positive 5/6. So that's the final answer. All right. So I think what would be the last and final thing we do today is let's make a little bit of a flowchart. I believe a flowchart will help you understand what methods to use when I'm trying to find limits algebraically. So our first step for everything is always going to be direct substitution. Always, always, always direct substitution. And one of two things is going to happen. You try direct substitution and you get some sort of number. That number can be a fraction, it can be a decimal. You get that number and you're done. Life is beautiful. Smiley face. Done. So we get the number and we're done. But what happens when you did direct substitution and you get 0 over 0? Well, what was 0 over 0 again? You should be thinking hole. So there's a hole in the graph. What was the process? Step 2 was to factor and simplify. And then step 3 was to try again. And then after you tried again, your answer should be perfect. That's it. That's the flow chart to help you. So it's either you get a number and you're done, or you get 0 over 0 and you have to factor and resimplify and plug that number back in. All right, that's it for today. If you have any questions, please let us know.